Right, so we're bringing halfway through this. This is basically a Black & Decker 7 litre digital 2-in-1 air cooler. I thought it'd be a simple case of a motor. It's a bit more involved, and I thought, well, do you know what, I better put the camera on. I didn't want it being a quick boring video. So I thought I'd just quickly go through what I found and how I'm getting on basically. So we go on to diode mode. First things I was looking at was these 5 transistors, so we've got T5 written on them. So the camera's zoomed out a bit because I don't have much room here. The thing's so big. So anyway, we go black onto pin 1. So hopefully you can sort of make out what I'm doing. And red onto the middle pin 2. We have 0.57 ohms. Or volt drop, sorry, and then pin 3, nothing. So I thought, oh, that transistor's gone, being marked as with a T. So if I swap them probes and go 1 to 2, we have 0.58, sorry, and then for pin 3, nothing. So these aren't transistors, they're actually triacs, so that T is triac. So I got that wrong, but yeah, the bidirectional triacs. So and I've metered them all out. I think they're thyristors, aren't they? 2 thyristors in one. And then the other one, I was a little bit concerned on, was I think this was a 10 ohm resistor. He's bang on 10 ohms, fantastic. Now this one, I thought, oh, that's a funny, it's L1, so that's actually an inductor, this green one. Now it's brown, black, red, which should be 1 kilo ohms. I assume you do inductors the same as you do resistor bands. So there's a lot of conformal coating on this board. Now reading 3.5 ohms, but obviously it is in circuit. I could desolder this and put it out and test it out of circuit. But what I thought I would do is, before I start messing around with the board, because it is all 240 onto this, well, it's 240 and it goes into this little power management IC down here and drops it from 240 down to something 5 volts or 7 volts, or I think it's 5 volts. Right, now I am being playing with 240 volts here. Before I do, I might as well just test this capacitor. So we're on capacitance setting. Let's go across to, and it should be 1.5 microfarads, and we have 1.467, which is perfect. Lovely. Now if I use my ESR meter, I have looked this up, and the CBB61, which this is, should be 0.1 or less ESR. Anything higher than that, it's failing, and we have 0.38. So that is sort of in the medium range of failing. I think it goes up to 0.8 where it's just failed. So I think we need a new starter cap. And the reason I say that, okay, this is in there. This is 240. Nothing else is touching. I'm going to plug it into the dim bulb tester. It's just out of shot there. If we turn it on, yeah, I don't know if you can see the power button. Oh, you can see the LED in the reflection. So that says on, speed 1. If that was the cap gone, that would start with that little helping hand. Let's see if we can see another light up. Speed 2. No. Let's see, speed 3. We've got full bulb. And we pull in 36 watts, so we can put at 1 amp fuse on. There we are, we have got it, but it's really slow and it doesn't have much strength to that motor at all. I could quite easily strop it with my finger. Let's not burn the motor out any worse than we have. So let's turn this off. Now that cap will be charged. So if I go to 240, because this is a 3-speed 240 motor, so basically you've got black from the motor, and then you've got red, white and blue being the 3 speeds. So our black from the motor goes directly to the incoming neutral. So let's get that probe squished into there. Now I've got to be so careful here because we do have 240 here. Now there's a lot of conformal coating on this board, so the readings are going to be jumping on and off. So it's got to be careful what I touch. So I'm basically just touching the very edge of the board, and there's no tracks near where I am. So instead of going on to the pads, 2.4, I'm actually going to go onto the wires because there's a little bit of space. We can get onto the wires easier. Yeah, you can see we've got no voltage there whatsoever. So if we turn it on, technically that should be speed 1. So let's go on to blue. $242 volts. Onto white, 238, and then onto red, nothing. Let's go on to speed 2. It seems to be putting voltage to both blue and white. Nothing to 3, but as you know, as soon as we put on speed 3, the motor tries to start. So I think either the coil's gone or that capacitor's gone. I'll just do it so it doesn't burn out completely. And onto red, we now have our 241. So either these two are shorted, or the output on the board is wrong. If it's putting 240s, both of these, and both coils are trying to pull at the same time, would it not start? Not 100% sure. Let's turn this off completely. This cap will still be charged, but there shouldn't be any voltage coming to these coils. And there isn't. So now if we go to resistance mode, okay, so we're still on the neutral because we're measuring the coils of this motor. So if we measure the red coil, which we know is speed 3, we have 447 ohms. Coil white, we have nothing. And then the odd time, what will happen is it will give you a reading, it will carry on climbing, and then just go to open line. Oh, unless that's got warm. Yeah, it is quite warm there. Let's go on to blue. Basically, I think we've got blown coils inside that motor. Right, so if I take it out of the neutral, if we had a short across blue and white, it could be the board and not the motor, and it's putting a short into the two coils. So I haven't actually tested that, it just came to me. Let me just check my probes. Yeah. We do actually have a, ooh, what do we have? 96 ohms. Let's see if that rises or stays constant. Right, 96, yeah, 95.4. Is that not moving? No. So I'm not measuring the coil. So if I was to measure a coil, we should have that. See that? Right, see that raising, and that's going to cut off in a minute. It probably gets to 60 odd ohms, and it's actually dropping. So it's reading the resistance to the coil, and then eventually this will just cut off. I'm holding the probes on nice and tight. If it's on too long, I'll just speed up through until it cuts off. And I'm not moving my probes. You'd think that's reading the coil itself. I think that coil's breaking down. You're not slowing down. Just take the probe off, go back on. There we go. Now it's rising. Now it will go up and cut off. So it's definitely an issue with either the board or the coils. So I think I need to desolder this motor. See if we've still got a short between the blue terminal and the white terminal. If not, test the motor between the two. But because it's a sealed motor, it's all riveted together. I mean, technically I could drill out the rivets and replace them. It's going to be a new motor. It's going to be for personal use, so this is for one of the bedrooms. Yeah, that coil's gone. It's not cutting that. So onto the white. Same. It seems to, once the motor's hot or warm, you seem to get a reading. And what will happen is it will continue reading the resistance of the coils and then just cut off. So it's sort of 99% sure the motor coils are blown. One or two. Okay. So let's desolder them and I'll bring you back in. Got that bit there. Right, literally just putting a soldering iron on to desolder this. Thinking, hang on, if it is the motor, there's not a clip or anything, so I have to desolder them from the board. Take a picture and so why don't I just snip these cables? They're more than long enough. If I can just snip these off, it's going to give me a colour code left on the circuit board. I can test that straight away, and it'll be a lot easier. Then I can desolder these at ease. I'm not sort of balancing it in place, and so I think I'm going to do that. So I'm unplugged. I know the first two are the supply, so let's just get them as close as I can anyway. The board is marked live neutral, and then we know it's red, white, blue, and then we know the last two. Black is the oscillator, and then white is the pump, so that's for future me. That's our board 3. So basically then, because we still know where they are, we had a short between white and blue. I'll put my meter back on to ohms and go across white and blue. If I have still got a short, then it is the board. If not, it's definitely the motor. And we don't have a short, so it's not the board. That's one side. So we're reading the board obviously, so we've got 454 on red, and then white and blue. So basically it should give you 3 different readings: high, low, medium. So that's the 3 speeds. Nothing and nothing. I'm definitely on that blue. Yeah, them 2 coils are gone. 100%. Right, let's take this motor out, and I'll be back in a while. Right, so I've got a motor from a well-known Chinese import company. It's supposed to be an 80 watt motor, and surprising enough, the label's all scratched off. You can't read what it actually is. This is the starting cap that they sent. It was broken, clearly used, and it's got a screw mark onto it as well. Probably just make out there, so that's used. Unfortunately, that has to go in the bin. I can't recycle that, so I've just put some clamps leads on this meter, and we've got 0.1 ohms, so we can allow that. So basically what I'm going to do is test this motor and see if it's okay. This is clearly used. I mean, it's grubby, there's solder marks on it. I did complain and they want me to send it back, and I think it's £10 postage. This is only worth £17.30, so they offered me £1.73. Woohoo! Do you know what? Let me just see if I can get it working. From it works, then it's all good. So we're basically going black to red, as in one of the coils. So our red is going to be 403 ohms. Well, it's 4.6 really, because we've got 0.1, but let's just go with the big numbers. So 403 ohms. So if I go off of the red coil and just pick a white coil, so basically we've got 3 speeds onto this one. We've got, so white equals 506, which is correct. Let's see if we can get some induction through there. Yep, perfect. 506, and blue. So off of the white onto the blue. Let's see what that gives us. Gives us a reading of 572. So that's blue 572. Okay. Excuse me. So we got 9, 10, 11. 1, carry 1, 8. Is 8, 14. So we got 1481. Okay, so if we do power squared, it should be 57600. If I do it on a calculator, you'll know what I'm doing. So let me just start this calculator up. Right, so basically we have 240 volts times 240 volts, that's 240 squared, gives me 57600, and then divide by the total coil, which is 1481, will give me 38.89. Let's just call it 39 watts. So this is a 40 watt motor, even though they tried to scratch off the label. The original one would have been a 55 watt. Okay, we can check the balance on these as well. So if we go between coils, if we leave that on blue and go blue to white, we have 66. Yep, 66. And then say white to red. Gives me 102. So white to red is 102. And we need blue to red now. And let's see if this motor is balanced. So basically 2 of these figures should add up to one last figure, 168. Also, it's going to be a total of 168.7 because we've got 0.1, 0.6. Okay, so 168. Yeah, so 102 plus 66 is 168, which is what we've got, 168 with my leads. so that'll be right. And I've got induction for this motor, so this actually motor is okay. And if we go between the starter coil, I don't think we should get anything, honestly. I don't actually know. Even though I'm an electrician, I never dealt with motors. So 0.8 kilo ohms, and we have induction of the coils spinning round. So about that, that's my Ring doorbell. So basically, if we're looking at these resistances, the one with the least resistance will be the highest speed. So obviously 403 is the smallest, so highest speed is 3. Oh, happened to do it in order 2 and 1, so it is blue, white, red. Yep, which is right, because we normally do red, white and blue, 3, 2, 1. Yep, so this motor is actually okay, even though I bought an 80 watt and it comes up as 39/40 watts. Okay, so I'll be happy to fit this into it. So let me get this ready and we can solder it in place. Right, so this is the original power board, so let's prep this power board before we go any further. So we've got our supply coming in, our 3 speeds being red, white and blue. We've got a black and a white, so one's the pump, one's the fins, so the oscillator fins. So I'm going to pull off this gunk, desolder these, have it all ready, so when we solder in the new motor it's basically ready to go. So I'm going to use a little bit of IPA, just loosen up this adhesive. Get it under there, and then we should be able to just use a pair of tweezers, lift it off, and I can just use some hot glue just to support those wires, because obviously the fan's going to vibrate, and it just secures the wires in place. So all I'm doing here is getting rid of this gunk. Right, so that's the wires released. Let's give it a nice clean while it's still warm. I'm going to leave my cotton bud everywhere. Right, so that's that prepped. Let's get it back in the machine, back in the moment. Right, so we've just used a bit of plastic as a spacer for now. I do have a lathe and the workshop's a bit of a mess, so I can make some proper spacers for it. This is basically just to see if we can get it working. Got a bit of play on the motor and it seems to be running quite nice. So we've soldered on the original starter capacitor, so let's get some heat shrink. I think we'll go with this one. So 3.5 mil. We've basically going to insulate these wires. There we go. Let it overhang slightly and that will close up. And it's going to be double insulated because it's inside the casing as well. That should be good. So, hot air station, set 200 degrees. Basically we're just insulating them wires then. A bit of heat on the end so it closes down. Right. That's them insulated, so let's get the board in situ and I'll bring you back in a second. Right, so let's get this power board back soldered on. So we've got a red cable here, which is our speed 3. Okay, red, white. So I have put flux onto this already. Right, so this is basically ready to plug in, and then I will put it all back together. So our fan's free, balance the back on, plug in the control board. Let's put the dim bulb tester on. Both breakers are off. We should see a flash. And then we'll capture onto this one. Right, there's no caps in here. So let's turn it on. We have fan speed of 1. Go on 2 and it should get brighter. There we go. And 3, brighter again. Perfect. Let's put it back down to 1 just for now. If we do oscillator, you should see this motor moving. Can just about make it out there. That is working. And if we do fan, you should hear this gurgle. Or oh, that's this one. Here we go. Not sure if you can hear that. Yeah. Perfect. Right, let me get back together. We can do a test on it. Excellent. One moment, please. Right, so let's give this thing a test. Sorry about the state of the workshop. That's a second fan that I need to fix. I haven't had a chance to look at it yet. Anyway, so let's see if the remote control works. Where are we? We're over here. Oh, let's switch it on. See if the remote control works. Perfect. Let's go to speed 3. We're pulling 38 amps. So I can turn on the 1 amp on the in bulb tester. So we go speed 1, speed 2, speed 3. It's 27 degrees in here at the moment. So you can just about see that. It's backwards. It may be backwards for you. So we've got 26.9, 26.8, so it's definitely cooling. We can hear it anyway. So let's turn on the cold air section. So this is where it draws water up, drops it through a filter, and basically it blows cold air through. So we're 26.6. Obviously you put ice packs on this anyway, or you could actually put ice into it as well. Which would be a lot cooler, but it's, oh, do you know what, it's lovely. It's 28 degrees in the workshop at the moment. But yes, this is definitely working, up running. Another one saved from landfill. I think if I put an ice block into this, oh yeah, 26.5, so this will cool down. So excellent. Hopefully you can hear me over the fan. Let me turn it off quickly. And I'll do some more videos soon. Hopefully I'll be fixing that one. It's a John Lewis 2 litre air cooling fan. Okay, thanks for watching. See you again soon. And there it is, pride of place in the front room. This was going to go up at son's room, but I've got that John Lewis one. It's a lot thinner, so I think that would be perfect for him. It's lovely and cool in it. It's only on number 1, so a great safe. Thanks for watching.